Welcome back, everyone. So we're now moving into a set of lightning talks. So this will be the next 45-minute session before we break for lunch. And so I'm going to introduce each one of our speakers sequentially as they come up. And time permitting, we will also be able to take some questions for each one of the speakers after their talk. So first, I'm going to bring up Rachel Thomas. You met Rachel in the previous panel. Rachel's founding director of the University of San Francisco Center for Applied Data Ethics. That group aims to address harms such as disinformation surveillance, algorithmic bias, and other misuses of data, which is why we had her in the previous panel. She's also co-founder of Fast AI. She talked about that a bit, and I think we're going to be hearing more about that in this particular session. Because right now, this session is really about democratizing AI. Okay, so we've seen the possibilities. How do we actually make use of this new technology? So Fast AI created this practical deep learning for coders course. The emphasis for Fast AI has been on students with diverse backgrounds, with small data sets, and with very little computational power. Now, that's sort of the strength of Fast AI's offering in particular. And I just want to say that, that Rachel was selected by Forbes as one of the 20 incredible women in AI. Welcome, Rachel.
Cool, thank you. Yeah, so I'm going to talk about some of the work of Fast AI, which is a nonprofit research lab focused on making AI more accessible to a broad variety of people. And we do this through a few avenues, including an open source library built on top of PyTorch, research into the techniques, and also education, which is what I'm going to focus on here. I should also note that our material is all available online, completely for free, so this is not a sales pitch. So I wrote an article earlier this year about some of our students with Fast AI, and I wanted to share just one of their stories with you now, which is Cory Spencer. So he's a Canadian dairy farmer, and he wanted to learn AI to diagnose udder infections earlier. And this is an application I never would have thought of because I don't know anything about goat udders or dairy farming. But apparently this is kind of the major issue in the industry. Infections can cause irreparable damage to goat udders before they're diagnosed. And he was successful at creating a device that uses heat sensors, identifies infections earlier so they can be addressed. He's spun this off into a company, EIO Diagnostics, and has moved on to robotic milkers, which they have for cows, but not for goats yet. Another student I want to share about is Helena Sarin, who's an artist, and she has decades of experience both as an artist and as a computer programmer, which is really fruitful. I think she's doing some of the most innovative work in AI, kind of AI-generated art. She uses all artwork that she created as her training data. She gave a great keynote at I/O Festival that you can find online about about her process. She's also been interviewed in Art Gnome. And she makes an analogy with kind of AI-influenced art as kind of comparing it to forms like printmaking or Raikou pottery, where the artist has this talent and kind of a craft, but there is an element of randomness in how the results turn out. And so today I just want to briefly address a few myths about AI that kind of commonly keep people thinking that AI may not be for them, even when it may be within their reach and may be a useful tool for the problems in their domains. So I'll start off with the first common myth is that you need a computer science PhD from Stanford. You'll often hear companies talking about this, feeling like they can't hire the talent they need. This is not the case. Another student story comes from Melissa Fabros. And so Melissa was a PhD student in English literature, focused on American poetry. And she changed careers many years ago, and I've been her teacher twice, first when she was becoming a computer programmer, and later when she got into data science and machine learning. But she's been working at Kiva for the last 3 years, and Kiva is a nonprofit micro-lending platform that lets people make and receive small loans around the world. A typical loan recipient is someone like Elizabeth, this Kenyan farmer. And Melissa discovered a few years ago that computer vision programs weren't recognizing pictures of Kiva users. As it was mentioned earlier, a lot of these programs were trained almost kind of entirely on pictures of white people. And so 2 years ago, Melissa won a challenge to fund kind of building a different data set. And I should also note that this was not for facial recognition. This was just even kind of recognizing that there's a person in the picture, but gathering a more diverse and representative data set. Second myth that we hear a lot is that you have to have, quote, big data. And I think big data was this very kind of harmful marketing buzz phrase, but that's often not the case. So 2 years ago, after the first week of class, one of our students, Nikhil Balaji, downloaded just 30 images of people playing baseball and people playing cricket, and that was enough to train a classifier to tell the difference between the two. I should also note that when I refer to our students, these are mostly working professionals, adults, kind of learning this part-time on the side. And the reason this works is due to the technique of transfer learning, which I think Brian mentioned briefly earlier. But transfer learning is where you have a network trained on a very large data set, such as ImageNet, and then you fine-tune it to your smaller data set, perhaps chest X-rays. And this is a different data set, different type of images, yet it's pretty successful with allowing you to train accurate models on the new data set. And the reason this works is because the lower layers in a neural network, or the early layers in a neural network, are learning generalizable features. And so in the case of computer vision, that includes corners and circles. And then the later layers are often more specific to what you see in your particular data set. So for ImageNet, that might be dogs or unicycles. And Brian talked about language models that are using transfer learning. And so kind of the power that we're seeing with transfer learning applied to natural language processing as well, not just computer vision. Third myth is that you need expensive computational power. So you'll sometimes hear about studies that come out of Google where it costs like $50 million just to run the study because they use so many computers and ran them so much. However, most practical real-world projects that I've worked on or know about can run on a single GPU. GPU is a graphics processing unit. NVIDIA is one of the big sellers of them. You may already have a GPU in your computer that you can access, and if not, you can rent one in the cloud. And I should note that, so GPUs are what are used to render computer graphics and video games, but it's the same type of computation that's needed to do deep learning. And so to share a student story, and this got chopped off, but his Twitter, this is Jason Antick's work, his Twitter handle is Citnaj, C-I-T-N-A-J. And then can you start playing the video? Or actually, I can start playing it. So notice he's taken a black and white video here, and he's added color to it. And so this is, I think, a really fun application. This is work of his called De-Oldify that's available online. He started off with black and white photos and then moved to video, which was a very very challenging problem until he broke it. Let's watch another one. So again, starting in black and white, and then it's learned to add color to the video. And something amazing about this is that he trains this on a single GPU. So kind of debunking the narrative that you have to have hundreds or if not thousands of GPUs or really expensive computational power. Oh, and here's the music. It's a fun application. And so that's Jason Antick's work. Oops. All right. Another example of not necessarily needing more computational power comes from Stanford's Dawn Bench competition. So this was a competition to see who could train ImageNet to, I believe it was either 93 or 94% accuracy, the cheapest and the fastest. A team of FastAI part-time students entered. They were competing against teams from Google and Intel that had access to far more resources. Yet, at the end, Fast AI had the lowest actual cost, was the fastest on GPUs, fastest on a single machine, fastest on publicly available infrastructure, and faster than Intel's entry that used 128 machines. So really, really proud of them for this work. That was very, very exciting. At the time, Google beat our team using TPUs, which is a kind of new type of computer chip that was not even publicly available at that point. However, 4 months later, Fast AI released versions that were 40% faster than Google's TPUs. So that was pretty exciting. It was covered in The Verge and MIT Tech Review. And Jeremy wrote some great posts for the Fast AI blog talking about the techniques that were used. And many of them are kind of surprisingly simple in hindsight, but were things that nobody else was doing, such as starting with lower resolution versions of the images to train faster initially, and then upping to high resolution versions later on to get the kind of more precise accuracy. But this really kind of underlies something I deeply believe, which is that innovation comes from doing things differently, not doing things bigger. And this is the value that people from other domains and other backgrounds bring to the field, kind of by having a different way of seeing things and a different way of doing things. And then kind of final myth is that you have to spend years studying advanced math before you can use AI. So I'll just briefly say our course, at the time, we first launched it 3 years ago, the only prerequisite was 1 year of coding experience, and it took you to state-of-the-art results. So this was kind of unheard of at that point because a lot of the materials assumed you had a graduate-level math background previously. And I do have a PhD in math, but I found I got frustrated with how so many other materials were just about the theory and weren't giving kind of the practical tips you needed to use this technology. Our teaching philosophy with Fast AI is really inspired by Paul Lockhart's A Mathematician's Lament and David Perkins' Making Learning Whole. But Paul Lockhart writes about this nightmare world where children are not allowed to sing songs or play instruments until they're in their 20s. And they need to spend 2 decades transcribing sheet music by hand, learning formal music theory before we let them try singing. And that's absurd, but that's how math is taught. We kind of save a lot of the most fun and creative aspects until everybody else has gotten frustrated and dropped out of the field. And so our goal with Fast AI is to kind of get people doing projects right away, even before they understand the underlying details, and then that helps provide the motivation to dig into those details as time goes on. Then in the interest of time, I may skip through. I'll just show a few of these. After the first week of class, we had a student from the Caribbean creating a classifier to tell the difference between masqueraders and regular islanders. That was cucumbers and zucchinis. A student from Panama City distinguishing between the old form of their buses and new ones. This is looking at batik classification. A lot of interesting applications and kind of to get people using them right away. And then finally, I wanted to address, particularly since I was on the ethics panel earlier, and a lot of my work focuses on ethics now. Sometimes people ask me if it's dangerous to make AI accessible to more people. I believe that what's dangerous is having a homogeneous and exclusive group creating technology that impacts us all. Oh, thank you.
All right. So our next speaker, Teemu Roos, is visiting us here from Finland. He's, he's associate professor of computer science at the University of Helsinki. I should say a little shout out to my friend Eetu Makkila. Thank you for introducing me to Teemu, who's also at University of Helsinki. Teemu's here now in his capacity as an educator in AI, in machine learning, and in data science. And he's responsible for what many of you might have already heard of, this Elements of Artificial Intelligence. It's an online course for non-experts. Teemu arrived a day or two ago and has already been in the waters off of Pacifica. He's an avid surfer and not at all daunted by our Northern California shore, so I'm very grateful to him for coming. Thank you, Teemu.
Okay, so thanks for the introduction, very kind. Thanks also for the organizers for the invitation. Always happy to have a chance to visit something where it is so pleasant and warm compared to where I'm usually at. I also thank for everyone for attending and listening. I will start actually not speaking myself, but I will first give the floor to one of our learners on the Elements of AI course. So let's see if we can give you a quick video here.
Artificial intelligence is like electricity. It will shape our world in ways we cannot imagine. Its masters will control how we live. AI is power. In Finland, we believe it belongs to everyone. With the help of the University of Helsinki, we built a free online course called Elements of AI. It combines our national strengths, an exceptional education system, and leading technological capabilities to give anyone, anywhere, the tools needed to understand AI. And it's taken our country by storm. Launched just last year, more than 130,000 people have signed up for the course globally, including over 1% of the entire population of Finland. Most importantly, Elements of AI has cut across gender, age, and socioeconomic lines. More than 40% of sign-ups have come from women, while 25% of all users have been over the age of 45.
Tämä tekoäly, niin se ei ole mikään tulevaisuuden hirviö, vaan se on ihan arkipäiväinen asia ja se on ihan hauska asia. Kyllä mä suosittelisin tätä kurssia kaikille, jotka haluaa niin kuin pysyä ajan tasalla, et edes katsoisi, että mitä se on, iästä riippumatta.
Now Elements of AI is going global. The President of Finland has urged everyone to take it. We challenged the Swedish government to adopt the course, and other nations have followed its lead. With participants from over 110 countries, Elements of AI is already a worldwide success. AI is a human right. We are changing the way the world learns, and we want you to join the movement.
There we go. So I will return to the actual course first, but I will start rewinding a little bit behind and backwards into the motivations of our initiative. And as Rachel, I will actually also start by looking at a few myths. I will not go into these in detail. I will just like to use them to illustrate the idea and the issue that in the general public, the awareness on AI is really nowhere near where we'd like it to be. And that also shows in the public media and the discussions. And this is really, to many of us, rather frustrating. And the illustrations that we get, for instance, is a thing that is a constant annoyance with all kinds of robots dominating the visual imagery around AI. So as I said, I will not go through these like Rachel analyzed her myths. We might want to get back to these offline, but rather than that, I will start or go forward and argue why it is important that we do discuss myths and we do bust the ones that need to be busted, and then we deem plausible or confirm the ones, just like in the TV show, the ones that stand our test. So why do we need to get rid of myths? I'm not saying that we need to get rid of all myths. I mean, mythology, of course, it would be really dangerous to say in a meeting with librarians that myths are not worthy, but I talk about other kinds of myths here. So the everyday cost of ignorance is that, or fear rather, is that people don't adopt all those cool and useful and beneficial applications of AI in the society. So this is a kind of a readiness issue in adopting things that we're now able to do. Then there is the scientific cost, which means that if people feel negatively about it, then the funding decisions, which are to some extent politically based, they will steer research funding away from AI, we won't get our countries and regions investing enough in the research that needs to be done. And as a consequence of that, if we don't have local top-level research, we don't get local top-level innovation. It is not possible to just expect that other countries or other maybe corporations do the research for us, and we would simply apply that. But even these three issues are, I think, not as important as the one that I really wanted to talk about, and that is the societal cost. So this is the one that I really like to, or that sort of keeps us motivated, and this is what I call the societal cost of ignorance. So if the general public are unaware of even the basic principles, again, it's not a requirement to have a PhD in maths or something else. It's really being able to understand what are we talking about when we talk about AI, what are the use cases, what are the decisions that we need to make in terms of regulation and so forth. The problem is that people really can't form an informed opinion of things, and therefore they can't really actively be involved in the public discourse and the democratic decision making that we need to go through to regulate AI. And of course, the idea here is that yes, AI is a tool, and any tool, it can be used for good or bad. But I really make a point of not putting a full stop ever after that sentence. That sentence is true, but it's not sufficient. So we need to follow it by saying that, okay, everybody needs to realize that we need to face some issues, and we need to make some decisions that are eventually policy decisions. So political decisions in the sense not in a party politics sense of who to vote, rather about which kind of regulation needs to be done. So that's my kind of claim about what are the current most urgent needs in terms of AI. They are political decisions to be made. Again, if you apply AI for certain purposes, it's really not the algorithms that we are researching today. Most of the time, it's more like algorithms that were researched maybe 20 years ago or even 200 years ago. And with those algorithms, we can do a lot of harm or we can do a lot of good, and that's the most urgent issue in my thinking. Okay, so what do we do then to get rid of those myths and get beyond them? Of course, anybody who has experience and expertise needs to be able to and willing to share that to as many people as possible. And journalists are, of course, in a critical role in mediating that message. And there's a lot to be said about the clickbait headlines and again the illustrations that go with them. I used to go around giving talks that were entitled "Forget the Terminator," but then I thought that that's probably the worst way to get people to forget about something, so I don't do that. But that's what I want to say in any case, most of the time. Also, the audience who read those headlines and hopefully read some of the stories as well need to be able to be more critical about what they're reading and calling BS when they see that. But all of that hinges on being able to access reliable knowledge, and that really calls for educational activities. Offering lifelong learning, offering education for children, schools, universities, any educational institutions, and it should be accessible for all. And this is really in a key position I'd like to mention coming from Finland in the Finnish AI strategy, which, yeah, okay, so you're probably reading the slogan of one of our meetings. Well, Stanford weather today isn't so wonderful either, but the Finnish AI strategy really focuses on applications of AI, on adoption of AI, obviously also top-level expertise, and we have really created a lot of initiatives to support and facilitate that. and new collaborations. So sort of togetherness is betterness in that sense. Okay, so what did we do in concrete terms? I'm coming back to the course that I started off with in terms of the video. We have created a course called The Elements of AI. Some of you might have already seen it. It's completely free. It's online. You can do it at your own pace. It's maybe maximum 30 hours if you really sort of go slow and sort of try and digest everything there is. It's an example of the collaborative nature of how we do things in Finland. It's a university and private company collaboration, which we sort of jumped into completely pro bono and out of the interest to facilitate better AI readiness and high level of discourse in the public. And it's not, certainly no math PhDs, no math degrees at all required. There's no complex maths involved at all. High school students were the beta testing groups, for instance, and there's no problem for them at all. Also tested it on my kids, so at least a 13-year-old was fine. And it really doesn't discuss too many of the algorithmic issues, or it's really not about building skills. That's of course needed, and Fast.ai, for instance, is doing a wonderful job at democratizing the skills needed to produce working AI applications. We're really focusing more on the awareness side of things and understanding how things work, and basic things like statistical thinking, machine learning, neural networks. Well, I wouldn't maybe call those basic things, but sort of the basics of those things are the ones that we want to teach, and then discussing the societal implications once people have the basic building blocks in their head. And we have already 2,000 and 30,000 participants. It's might be outdated number. It grows like 10,000 a month or so in 1.5 years. And it's, yeah, well, there's a lot of recognitions that as a Finn, I'm embarrassed to boast too much about. But there it is. We're ranked higher than courses at Berkeley, which is of course something that it's very good to say here. There is like a ... thing there. I don't want to go into that. Yeah, we got this MIT prizes 2 weeks ago on Inclusive Innovation Award, which I think is a very good award in terms of the purpose of the course being to build something that supports inclusivity. Right, so I kind of it's better if you go online, just go Google Elements of AI or go to the URL. You'll find what it's about. AI literacy or literacy was mentioned in the morning, so I think this is a good way to express what we're after. We're also after diversity by designing the course so that it's not sort of only matching the classical, young dudes in hoodies kind of style of what is expected. And we're going global. We've got, it's in English, it started in English, we translated it into Finnish, and now we've launched it, in this kind of country challenge way, competing with the Swedes, and last week in Estonian. And again, the ... thing is something that we will be able to announce next week. So the big goal would be that we'd be able to partner. This is kind of the call for action that you need to finish all talks with, apparently. We need to partner with a lot of collaborators to make it big, make it bigger, and make it global, make it sort of reach everyone that we want to reach. So that's basically everyone. So we need a lot of partners, and the goal, 2018, last year, the goal was 1% of the Finnish population. Now the goal is 1% of the global population, and of course not the 1% that people often talk about, the privileged 1%, but basically the other way around. And I'd just like to, the last thing that I have, I guess, time to say is that the diversity things that we have achieved, it makes me extremely happy. Overall, we've got 38% female, and it's really amazing that in Finland, actually, we've got 57% female users, which I don't see when I teach AI at the classroom. So that's something that we're extremely happy about. And again, we'd really want to work with you and your organizations if you share this vision, and I'll be happy to discuss ways in which we can reach this vision of ours. Thank you very much.
And we have time for a question for Teemu, if anyone would like to ask a question while we're getting set up with Emanuel. No.
There's no need for a PhD in maths to ask questions either. Right, so.
Do your classes use AI in their implementation or
Glenn,
design?
could you take that mic?
I can repeat the question.
I'm just wondering whether your courses use any AI in their design or implementation.
Right. So that's a great question. Do we use AI in educating people about AI? Kind of a sort of two-way thing. We don't use it too much. I'm a kind of a old school person in terms of teaching, although of course this is online. We do a lot of. I mean, there's some auto-graded exercises, but they're kind of not. It's more like computing rather than AI sort of as such. We do some peer grading, which is great because it builds that community and gets the people, sort of other people's views on things, but not really AI as such. We're, of course, working on using this amazing amount of data in learning analytics and sort of learning more about our users and making things better, but it's not in the course itself. It's not like automated components there. So, thanks.
Thank you so much, Teemu.
Thanks.
And for those of you who will be around for the workshops tomorrow, Teemu is going to be giving us an introduction there to machine learning. So earlier this year, some of my colleagues here at Stanford Libraries pointed out this headline in TechCrunch, which was MIT's new interactive machine learning prediction tool could give everyone AI superpowers. And that led us to Emanuel. So Emanuel is a postdoctoral associate at MIT's Computer Science and Artificial Intelligence Laboratory, where they are developing this tool. So he's currently working on these kind of interactive tools for visual data exploration and analysis, what is being called drag and drop analytics. So the system, the idea is that the system lets non-specialists use machine learning tools to make predictions for all kinds of research, and thank you.
Thank you very much. So today I'll be talking about this project called Northstar. I want to point out that this is a collaborative project between Brown University and MIT, and there's a lot of videos and information to be found online if you're interested in further readings. So if we look at how data science, machine learning, and AI are being applied today, this is basically what it looks like. It's a lot of coding, a world that is reserved for trained data scientists with a computer science and some programming backgrounds, right? And the whole goal behind Northstar is to change this and make data science accessible to a broader range of users. So Northstar's target audience is what we sometimes call data enthusiasts, so people who have data, care about data, and need to analyze and understand data for their day-to-day jobs, but who, again, don't have PhDs in machine learning or statistics, and who do not know how to write Python code or any other type of programming languages. So the system started out with building a system that works on these big interactive whiteboards that you can use in conference rooms or classrooms, but then it kind of gradually spread to other devices, so now the system actually runs on anywhere where you have a browser, so you can use it on your iPad, on your regular laptop, but it also works really still well on these big interactive whiteboards. So the easiest way to actually understand it is to see it. So I'm going to switch and try to give you a demo here. Hopefully the network's not letting me down. All right. So this is the system basically. So as you see, it runs in the browser. And one of the first things I can do here is I can look at all the data sets that I have available. So these are all a bunch of things that I imported before, but you can think about this, you can drag and drop a spreadsheet into the system, or you can connect it to a SQL database, or basically any kind of data warehouse where your data might live. So for the first part of this demo, I'm going to use this Mimic data set, which is a medical data set. And when we look at all the attributes of the system, of the data set here, you'll see that it contains a bunch of these what's called ICD-9 codes. So these are disease codes. It has a bunch of demographic information about patients, and then a whole bunch of blood testing results that come for each patient. So we think that the system is really good to support people who care about this type of data. So, doctors, medical administrators, and they might have questions that they want to answer over this type of data. So one of the common things a lot of people think is that heart failures are more common in men than in women. So if you have a hypothesis or a question like this, you can go about answering it by first maybe, we drag out the heart failure attributes. And in this case, this is a binary attribute, so it will show you the patients without and the patients with a heart failure over all your patients that you have in your data set. Since we care about how gender relates to this, we can drag out that one as well. And then all these elements can be freely arranged. You can get more screen real estate, so it's basically a big unbounded canvas where you can lay out these visualizations the way that matches your mental model. And one of the key aspects of the system is that you can connect these things together. So if I draw a link between these two attributes or visualizations here, what this allows me to do now is to say, I want to look at the heart failure distribution, but only for the men subpopulation. So I'll select males here, and then the visualization on the right will be filtered down to only show you the distribution of heart failure for the patients that you selected. So doing this, I can toggle between men and women here, and I can kind of see if I observe a change on the right-hand side. In this case, it's a little bit hard. So alternatively, what I can do is I can say, I want to look at people with a heart failure, but if I bring it close over here, I will sort of highlight patients with a heart failure in the context of the gender visualization that we're looking at there. So doing this, then there's a whole bunch of things on top of visualizations you can do, the standard changing aggregation functions and things like that. You can also normalize axes to kind of read out relative difference. And what this will help us do here in this case is to see that actually in this particular data set, women have a slightly higher chance of having a heart failure than men. So using these simple tools, you can then imagine that a doctor or a medical administrator can start building more and more complex questions over their data, right? So maybe they can say they want to look at women and they want to see their heart failure distribution, but also women maybe of a particular age group, let's say 40 to 100, and they can visually, almost playfully interact and dissect their data this way. So one of the things that you see here when we look at this age distribution is that it looks a little bit funky, right? So there's a lot of people in the 0 to 20 bracket, and there's people with age over 200, so there's something weird going on here. And this is kind of a common problem in applying machine learning or AI in general, that data is oftentimes not clean, and you might have to apply some data cleaning and transformations as you go. And so this is what we might want to do here. So one of the things we might want to do first is say, let us inspect the 0 to 20 age bracket here a little bit in more detail. And we can do this by using the same tools as before to get down here a filtered view of patients between 0 and 20 years old. And what we'll find out here is that there's a lot of patients where the age is exactly 0. And when we talk to medical practitioners, they told us that these are not newborns or anything like that. So these are actually data entry errors. A lot of hospitals, for various reasons, don't record age, so they will show up as zeros in here. So this is something that we have to clean up if we want to do any follow-up analysis with age. And one of the ways of doing that here in the system is you can say, I want to create a new attribute, and I can give this a name. Let's call this clean age, for example. And then I can instruct the system, what do I want to have as part of my new attribute? So here, it's probably a little bit hard, but there are some good values here in the teenage years, so I'm going to select those here. So I want to keep all of those, but I want to leave out patients with age 0, and I'm basically going to feed it into my new attribute that I'm creating. At the same time, I want to probably keep everybody that's kind of in this range here, 20 to maybe 100, but leave out the 200 age people. Interesting tidbit here, before they release this particular data set, they have to anonymize it. And one of the ways of doing that is everybody that's over the age of 97 just gets a 200 as kind of a status code in their age column. So again, this is a data entry error, if you want, that we need to clean up. And so, yeah, we selected patients between 20 and 100, and we're also going to feed it into our new attribute. And basically what we end up with, without having to write any formulas or any code, is a cleaned up version of the age distribution that looks a lot more what you would expect from it. So now this works as any other attribute, so maybe further down the line, we want to look at maybe, again, how heart failures are related to age. We can do the same highlighting operation here. If we normalize again, we'll see this kind of trend that you might expect, basically telling you the older patients are getting, the more likely they are to develop heart failures. So using these tools, one of the things a lot of doctors actually care about is what's called co-occurrences among diseases, so which diseases co-occur frequently together in patients. So for example, we could find out insights like this by saying, I want to look at patients with an infectious disease, and then I want to see how their chances of also having a metabolic disease at the same time look like. But there are other more algorithmic or statistical ways to get at these same insights when it comes to co-occurrences of diseases. So for all these kind of use cases, we have a whole bunch of algorithms and operators that are exposed in the system, and the one that works well here is this frequent item set one. So I can drag this out, and then I can use, again, drag and drop to say I want to run this over metabolic disease, infectious disease, and maybe let me just add another one, blood disease. And what this particular operator will compute or is looking for are frequent patterns among these three input diseases that you gave it. And it will tell you that the most common pattern is just patients with a metabolic disease by itself. 52% of the population have it. But then if you go down the list, you see that metabolic and blood disease co-occur in about 22% of the population. So maybe, again, we're interested in these disease patterns, but only for a subset of our patients, maybe, again, based on age. I can select people over the age of 50 here, maybe. And if I'm using the same linking technique as before, I will instruct the operator to recompute, but now only over the subset of patients I selected, in this case, revealing that a lot of these diseases are more common in the slightly older population of our patient population. So the way to think about this particular example of this frequent item set thing is just as kind of a stand-in for any advanced statistical or advanced data mining operator. But the key idea is that we can expose these kind of more advanced operators in the same visual system and enable, again, domain experts like a doctor to use them within their same workflow as everything else. So going one step further from here, one of the things we might want to do if we're a doctor is if we care about a particular disease, let's say heart failure, can we build a predictive model that would help us predict when a patient comes into our hospital if they're likely to develop a heart failure or not? So for all these kind of prediction tasks, we have a predictor operator that I can drag out, and then I can say I want to run this, or the target of my prediction, the thing I do want to predict, is heart failures. So I just use drag and drop it in here. And I want to use all the available data, all the available attributes of the system to solve this particular prediction task. So what we're doing here behind the scenes is we're kicking off what's called an automated machine learning engine that is basically looking automatically for end-to-end machine learning pipelines that are solving the particular problem the user specified, in this case here, how to predict heart failure given all the data that we have available. And so this automated machine learning engine was developed as part of a DARPA project. And as you see, as I'm talking here, results are coming back, and each of these results is a full end-to-end machine learning pipeline. So if I want to look at any of those, I can drag it out. And one of the first things I can look at, and this might be more targeted towards people who have a deep understanding of machine learning and AI, but I can look at what this particular pipeline consists of. So here I just see, if you know what a gradient boosting classifier is, you'll see that it's using that. It's doing the hyperparameter tuning for you at the same time. It does a whole bunch of stuff behind the scenes of giving you as good as possible solution for the particular prediction task that you inputted. All these models are exportable to code, so if I could take this and hand it off to my data science team, if I want to put it into production, or if I know how to write Python code, I could take this and tweak it further manually. And then we have we started working on a whole bunch of tools that, again, are more targeted towards domain experts with the goal to help them understand what these models have actually learned. And so the one thing I'm showing you here real quick is what's called feature importance. So the way to read this is the more to the right a feature is, the more important that particular feature is to make predictions for that particular pipeline. So basically, maybe unsurprising, age is really, really high up on that list, meaning that age is a good predictor for heart failures. So again, these are kind of just tools to help domain experts debug or build trust into what these models actually do and kind of see if what they come up with is reasonable. So everything I showed you so far is basically tabular, structured data. We have support for other types of data sets, and for that, let me just switch to another data set here. that talks about the IMDb. IMDb is the movie rating database. And so one of the things we have in here is we have movie posters, right? So we can use this as part of our data exploration pipeline. And you can imagine, so these are images, but you can imagine these could be PDFs or videos or basically any other type of data files. And what I can do here is I can say, I want to look at maybe the ratings of movies and plot it against the budget of a movie. And then there's one interesting outlier up here of a movie that's really, really expensive to produce, but only gets kind of mediocre ratings. So if I want to find out what that particular movie is, I can use the same filtering tools as before to find out what that particular movie was. And yeah, perhaps similarly, there's the kind of sweet spot down here of inexpensive to produce and highly rated. One of the things that stands out to me is that there's a lot of stand-up comedy people in there, which kind of intuitively makes sense to me. So again, images and other types of data can be used as part of your data exploration pipeline, but you can also use them to build predictive models again. So for example, I could say, I want to see if it's possible to build a model that would use the posters and only the posters to see if I can predict the genre of a movie. And I can set this up the same way as we did before. And here behind the scenes, to speed this up and give you interactive response times again, we make heavy usage of transfer learning techniques, a thing that we have heard before a couple of times. But again, just to kind of show you that it's not just structured data, but it could also be text or images and so forth. Yeah, I think this is a good stopping point. I just want to point out that we're still always looking for people who will want to try out the system or who have interesting use cases or interesting data sets to put into the system and to play with it. So if that's something that you might be interested in, please feel free to reach out to me or talk to me later today. Thank you very much.